Okay, this is my lab report for Lab 1 by me, Nikita Crisp. So for the introduction, this lab worked off of the concepts of charge and properties of matter. Throughout this lab, we can see the fact that matter can have temporary induced dipoles due to being exposed to an outside electrostatic force, such as a charged piece of tape. The main goal of this lab was for us to calculate the amount of excess charge on a piece of charged clear tape. My results concluded that the ratio of electrons to atoms was around e to the negative 8, meaning that the tape lost many electrons, making it positively charged. So for presumptions for this lab, in the lab I used the principles of force and electric force in order to determine the charge on the tape. In knowing that tape A was exerting a force on tape B, one can surmise that there must be an equal and opposite force acting on tape B as well. This is due to tape B having zero acceleration or momentum, meaning it wasn't moving, it was stagnant in the air. So this also meant that the net force acting on tape B must be zero. And so I concluded that this opposite force must be force due to gravity, and I concluded that the force due to gravity must be very close to the force due to the electrostatic force from tape A. More presumptions. If electrons were to have positive charge, then the calculated charge in my model would have turned out negative, and the tape would have lost positively charged electrons, which would make the resulting piece of tape negative instead of positively charged. So handling the tape as little as possible is important because the charge from the tape will transfer to your hands through contact and the rest of your body, and it will make the tape less repulsive to the other tape because you would have taken away its charge. It would have dispersed its charges through you, and it would have lost that repulsiveness. So this caused a issue with my experiment in particular because I was handling the tape too much and it lost its repulsive properties, and it did not make the tape above it float for a while. So for data and observations, the length of tape B was 21 centimeters or 0.21 meters. The mass of this piece of tape was 0.00021 kilograms. The distance between my two tapes when one began to float above the other was 1.5 centimeters or 0.015 meters. The magnitude of the gravitational force on the two pieces of tape was calculated to be 2.06 e to the negative 3 newtons. The magnitude of the electric force on the tape was calculated to be around 2.87 e to the 5 newtons. So for coding, in my code I have initialized the tape objects in the form of spheres, and then I created an electric field function like the one made in Lab 0. So the spheres here would just be representing point charges. So you would treat each tape as a point charge, as I did in my code. So I then calculated the gravitational force as well as the electrostatic force using the electric field function that I had written earlier in my code. Then I created two vectors that would simulate the gravitational force and electrostatic force acting on my tape B. And after this I created some print statements so that my findings could be easily understood by whoever was looking at my code when it was run. You can see here's my tape B, here's my tape A, here's my electrostatic force vector, and here's my gravitational force vector. So my computational model calculated that the charge on one piece of tape was 7.177 e to the negative 9 coulombs, and assumptions that were made when calculating the charge on the tape was ignoring air resistance on a moving object, treating the long tape as though it were a point charge with all the charge concentrated at the center of the long tape, and each U tape had the same amount of charge evenly distributed along the length of tape.